Most of you learned that an atom is mostly empty space between its nucleus, protons and neutrons, and electrons, and you might ask yourself, what exactly is that empty space? An electron's position is not defined by where it was a second ago, but instead by what's called a probability cloud. An electron has X% chances of being over here and a Y% of being over there. No one can certainly know where it is until an observer actually looks. And that's because the electron is in what's known as a superposition. This subatomic particle has a wave function, meaning it exists everywhere simultaneously. So, electrons are spread out around this empty space, and this area is known as an electron cloud. The quantum world is undeniably governed by probability. Einstein once referred to entanglement as spooky action at a distance. One particle can effectively know something about another particle instantaneously, even if those two particles are a universe away from each other. This is also known as quantum teleportation. In 2019, scientists confirmed that information could be passed between photons on computer chips even when the photons were not physically linked, and this is huge. String theory replaces all particles with tiny vibrating strings that twist and turn in intricate ways. And based on the way they vibrate, they gain the properties of different elements, like a photon, a quark, and so on. Another strange realm in the quantum world is what we call quantum entanglement. Once two particles interact, they become entangled. It's kind of like being linked together, but in opposite forms. If you measure a particle to have a positive spin, the other linked particle must have a negative spin. Let's say these two dots on the screen are a girl and a boy ice skating and facing each other. When they push off from each other, they head in opposite directions. If a third person measures the velocity and mass of the girl, they will know the momentum of the boy without ever seeing him. Classical physics would refer to this as the conservation of momentum, but in the quantum world, this is more like the entanglement momentum.